Yesterday, we had an international speaker with us. But before that, let's have a quick and a very condensed recap of yesterday's sessions. Yesterday, there were two sessions, one on AI and data analytics by Dr. Yogan Jayakumar, where the key themes that were covered was the introduction to AI and data analytics, the emerging trends in AI, applications of data analytics, challenges and ethical considerations, as well as the future directions. The key takeaways of the programs were AI and data analytics that are reshaping the industries and opening new opportunities. Ethical considerations must remain at the forefront of certain AI applications, and the continuous learning and adaptations are essential for staying relevant in the AI driven era. The second session of yesterday was very informative, and that was related to the intelligent app development leveraging generative AI Copilot by Mr. Vidyasagar Tejamurtula, where the key themes covered was introduction to generative AI in app development, capabilities of AI Copilot, key features and its advantages, the real world applications, challenges, best practices, as well as the future of app development with generative AI. The key takeaways of the program were the generative AI tools like Copilot significantly enhance development speed and efficiency. The integration of AI in app development is an evolving field with immense possibilities. Today, we have two very interactive sessions with speakers named as Mr. Rohin Koduri and Dr. Abhinav Kumar from DRDL and IIT Hyderabad, respectively. So, not to delay any further and to continue our journey to learn and get inspired meticulously, let's begin our first session today. But before that, I would like to invite our convener of this FDP, Dr. Papia Datta ma'am, to introduce us with the profile of Mr. Rohin Koduri.
Thank you, sir. Mr. Rohin Goduri, sir, is a very senior and experienced person in DRDL. He is the Deputy Director, Instrumentation Lab, Defense Research and Development Organization, Ministry of Defense. He has 25 years of research experience and expert in high-speed imaging, computer vision, and photogrammetry. He has done BTech in Computer Science and Engineering from Andhra University, MTech in Software Systems from BITS Pilani. He has several research papers and publications. He has received various awards in DRDO level and DRDO Lab Awards. So we are very fortunate today to have with us Mr. Rohin Koduri, sir. Sir, welcome you here in this session and please carry on, sir. Thank you.
Yeah, thank you, ma'am, for the introduction. As well, I feel proud, or what I say, a an interesting way of interacting with academia, because as a prime defense laboratory, we keep having our own projects, keeping our busy schedules and all. But in fact, today I am also not in station. I'm outstation for mission. In fact, I forgot that this today is my presentation. So, in fact, probably I don't know. Let me try to explain certain things because I didn't even complete my presentation last week. Totally, I was outstation for the past 15 days. So, anyhow, no issue. I hope all the audience or the participants would be able to grasp certain points which I would like to address here for the August gathering as well. I think all the the participants are all from various industry as well, the academia from all parts of India. Let me start my presentation and give some introduction about my activities as well, what from DRDO perspective and my laboratory which we are doing it. DRDL is part of the Missile Complex Laboratory, which is part of DRDO organization in Hyderabad. So this is one of the prime laboratories which is engaged in design and development of this strategic way of doing design and development of the strategic missile systems actually. Uh, Hope you are able to see my presentation, right? Hello, ma'am, can you hear me?
Yes, sir. You are audible as well as your screen is on.
Yeah, fine. Okay. Yeah. To start with missile complex programs, we have got different missile classes in terms of the design. When it comes to missile, when we say nowadays, so with context to AI, there should be some kind of an intelligence driven in our program, both with respect to the hardware and the software development. So here in DRDL at present, we are handling different class of missiles like ATGMs. They are called anti-tank missiles. So in this, we have got three different classes again. One is called NAG. This is a ground to ground kind of a missile, basically against a tank. The range is around 7 kilometers. Similarly, Helena, which is again from air to ground, it is against a tank target. As well, we have got a short range man portable anti tank guided missile, which is shoulder based kind of a thing where the user is again army. So almost all these three missiles are into production. So in this, we have got different technologies with respect to the propulsion, then the seeker technologies and the terminal phase guidance, which is driven through IR imaging. So, and when it comes to LRSAM, this is long range surface to air missile, which is having different ranges like M1, M2, and M3. The ranges again vary from 30 kilometers to more than 100 kilometers. And we have got a very interesting program where India is one of the top class, top four nations of the world, wherein we are doing research in hypersonics. That program is called Hypersonic Glided Vehicle, basically HCM and all, Hypersonic Cruise Missile. And we have got one more variant, which is an air-launched missile, which is also into production, is Astra. So Astra is air-to-air missile that the targets are again the aircrafts as well, the incoming missiles also. And one more program we have got is an intelligent NGR, new generation anti-radiation missile. The targets here are the communication facilities, the towers, etc. And one more missile which has gone into production is Akash NG, the earlier variant of Akash, which we have even exported to several countries nowadays. So, which has got a different seeker in terms of engaging the final targets. And when it comes to my area of work, I am into visual instrumentation. Basically, I'm an expert in high-speed imaging, wherein my capturing areas for all qualification testing, the flight trails as well the static tests vary from more than 100 frames per second to even up to 1 lakh frames per second. So all the videos or images are basically into you could say in terms of milliseconds to microseconds. So we all these subsystems are actually being tested before we actually do a flight trial. So hope I'm only talking, but I just want to know like if audience are able to hear and catch my words or anything else.
Yes, sir, you're audible, sir.
Fine. Anything else like in terms of
No,
clarity
it's
or
okay.
quality of
All
knowledge?
all
Fine.
fine.
Yeah,
All
fine.
fine, sir.
Yeah. Thank you. Okay. So as my topic says. So leveraging of AI for modern defense innovation strategy applications. So I'm talking in terms of the defense area where AI is going to have a major role. So this is outline of my presentation. So I'll just give an introduction on AI in terms of the application when it comes to the defense area. Second thing is AI driven innovations, how they're all part which is driven to apply for defense also. Then the next thing is how about the strategic application in terms of AI for defense. And as Madam pointed out that the challenges and ethical consideration which have to be looked about when we talk about this AI based applications and all, and the future outlook what currently we are at present and the way in which we are trying to look for the future. So, okay, when we talk about the historical context, we all know during the World War II how the technical advancements in terms of the weapon developments have been taken place. So, in good old World War, the Germans and the other countries like US and Japan were having the war scenario. So here the context was in terms of the radar systems during the World War II. Those systems played a major role when it comes to the incoming missiles when an enemy is attacking any country with respect to attacking itself, or even to have some kind of an anti-defense scenario in terms of the missile technologies. Of course, India in terms of the anti missile technologies is on par with the other developed countries. So when it comes to analyzing the incoming missile, which is a threat to its own country's defense. So the radar systems, which were all developed, were having very less terms in terms of the communication ranges, in terms of the data rates, the bit rates, and all. So that was one of the disadvantages in World War II, wherein there is no identification of or any other information with respect to the enemy capabilities and all. So in terms of the radar technology, now on par with many countries, India is also having several radar development programs. So we have got one of the laboratories called LRDE from Bangalore, which has got advanced radar development programs, which is supporting all of our missile programs here. And when you talk about a radar, so it is basically it is trying to find out the incoming missile threats or any other like drones or or communication jamming technologies and all. This is a wide area wherein here it comes to communication, then computing technologies, wherein and split spectrum technologies in terms of the jamming technologies when you talk about a drone being targeted and all. And when it comes to the threats, we have to have a powerful systems. We have to attack the enemy missile as well before entering into our zone. That is the first mode. And second mode is, even if it after enters, we come to our endo atmosphere zone, wherein we need to have our targets, like the incoming ballistic missiles, and our missiles have to be very faster to attack those missiles. Okay, so this is about early developments in terms of radar technologies, as well the targeting systems in terms of the attacking part from our side. So in terms of the strategic applications, so wherein we have different class of missiles like Agni class and all. So here, when we are targeting a missile which is very far away, we really have to compute all these strategic locations and all in terms of lat long and all. But precisely targeting needs accurate seeker systems. Here it comes in terms of RF seekers and IR seekers. In terms of RF seekers, India has been lacking behind because of several issues in terms of the materials, in terms of the what do you say, geographical location issues and all. But when it comes to IR zone and all, so India is on par with many countries. So for accurately hitting the targets. So this is some part of introduction. And when it comes to the digital technologies, so we all know that a lot of computer systems have gone into advanced process and all. Now we are into petaflops and more computational powers. So India is on par with many of the countries, and this command operations during the scenario, we have got a range called command communication and intelligence system range, so which is aiding all of our missile technologies in terms of adaptations to the present scenario of the world, wherein the data rates are very high. So for that, we need a minimum of at least 12 satellites in and around. And India have got its own sat nav, which is already in place. The first trials have been taken place, and we achieved fantastic data rates. These are all certain data rates which are again classified, so which I will not be able to tell in terms of the capabilities of Indian satellite communications. And when it comes to integration of network communications and all, India have got different networks, spread across, and they have been deployed all across, different borders as per the requirements from national security team. So in terms of the graphics and this communication technologies, so India is on par with, several countries. And now, as we talk about AI, so especially when we talk on AI, the first and foremost thing which is coming is a drone technology. So instead of having a different scenario, we actually deploy some kind of a drones with an advanced payloads carrying either a bomb or a missile or any other we can say chemicals or any other methodology to suppress the enemy. So this drone technology has come very fast, like in terms of the technical advancements in the recent scenario. So, so even these drones are going to aid us in terms of reconnaissance, in terms of the enemy capabilities or any other threats in its borders and all. So when we talk about drones, so all these things mostly the intelligence is coming through training of all these images or border scenarios, or even the map technologies and all. So this is one of the major advancements in the present day scenario. Okay, so when we talk about intelligence, I did not tell about AI introduction because most of our participants or the speakers might have already introduced on AI and all, which is utilizing the machines with the scope of having neural networks and natural language processing to have the advancements in human intelligence to be applied for various defense applications. And here when we talk about the AI in terms of defense requirements, so most of the things are being used in surveillance at borders. Then we need to understand the enemy's capabilities in terms of the what is a deployment scenarios. For example, when we talk about the neighbors and all, so the country needs. So instead of deploy, earlier scenario is to be different. Nowadays, with these advanced technologies, we have got several information, like intelligent information through reconnaissance and all. And implementation of these autonomous weaponry in the combat scenario. For example, when we talk about this present world, I mean war which is going on between Israel and the other countries, so we are able to see how advanced Israel is in terms of the strategic planning as well the logistic management. So, even before the enemy attacks, one country is able to do and solve its threats using these reconnaissance methods only. And how this is different with respect to other technologies, as we all know, robotics has been quite a what is a intelligent buzzword which has been in the market. Instead of avoiding humans, many of these physical machines which are there, for example, you can talk about mining, for example, uh, in terms of bomb threats or any other things. Instead of involving a human, we are able to deploy the robots which are able to intelligently find out the bomb threats or any other mines which have been deployed. And when it comes to automation, so instead of repeating, like for example, a very an automotive industry and all, wherein we are able to have production very faster when it comes to when we compare the human tasks, like some kind of repetitive productions kind of a things are being outrightly having a better advantage if we use robots and all. And when it comes to data analysis, we have got quite a huge amount of um, processing applications in AI. The entire range of data is being intelligently monitored and classified as well, extracted from a huge data in terms of analytics. So we call it as Python-based algorithms, or you can say big data analytics and all are playing a major role here in terms of uh, analysis when it comes to, we can say, even marketing as well, banking sector as well, and defense sector also. So AI basically is enhancing the defense strategy. One is when it comes to complex data management. Here we are trying to use our data in terms of the analysis. Like for example, when we started our design and development of a missile in terms of ATGMs in 1960s, so we don't have proper data and analysis about a propulsion system. For example, when I talk about a propulsion system which is driving the missile towards its target, we really don't have any information from the outside world how system is being developed and being used for the missiles. So what we are doing is the same scenario now we are applying to our missile systems. And once we developed these ATGMs, and under the IGMDP era, we had got 5 different projects. So all those data now is being digitized, and then complete information is being made digital operation, and then which is being accessed to all of our current projects, wherein we are able to utilize their old data and then analyze. Like for example, when we talk about a propulsion system, so this data we need not do certain more number of tests. And utilizing the earlier data, we are able to make it conclusion even in terms of control or onboard computer systems or even software development point of view. And when it comes to simulations and all, instead of doing an actual test, nowadays we have got several simulation systems in terms of systems engineering and aerodynamics or even computational fluid dynamics. We are able to analyze this data using these technologies and avoiding several tests before we qualify a subsystem or any other system for the missile design point of view. So this analysis and using AI-based systems are able to derive certain predictions as well. The computational dynamics are being used for getting concluded for a specific design for a subsystem into qualification criteria. And apart from this, I would like to mention also even this quality area, which is there. They all rely on a particular data which is already there under the documented part. So most of this quality and reliability team, which help us for progressing the system for or qualifying a subsystem, will be utilizing this data for quicker response and analyzing how the future systems are to be there in terms of improving the operational efficiency. Okay, so and when it comes to automated systems, we have got a lot of workload reduction and increase in terms of the accuracies. So apart from this, we also have some kind of a predictive algorithms which use Monte Carlo simulations and all, and we have got some mesh and grid technologies in terms of computational fluid dynamics, which is maximizing our resources in terms of simulations and all. And apart from this, we are also using this AI-based algorithms in terms of mission planning. When it comes to the users, for training and all, so we use these techniques in terms of the computer-based technologies and all for actually training the users in terms of the operational scenario, how things and all. And apart from this, we also have this program called interaction between the users, even right from the beginning. So we have got different programs, even when we call about DCPP kind of a thing, wherein the designers and are interacting with the users, and they'll be part along with us during the design and development phase. And the third and the one more important scenario in terms of defense is in national security, wherein the surveillance capabilities are being increased with respect to the enemy's identification as well, what kind of a scenario or what kind of a things are going on at the borders and all. So apart from this, one more major area, one we can say in terms of cyber security is nowadays many countries are relying on this kind of a many teams in we can say different countries are working on cyber say crimes and all. Even they are trying to target our defense establishments, websites as well, many other national you say banking sites, etc. So to get these things out of threats, or you can say any other developments, so we have to be having powerful algorithms which run against these cyber attacks. So AI is going to have a very advanced and challenging you can say in terms of the defensive as well offensive uh, scenarios here in terms of national security. When it comes to the innovations, you can say we have got different UAVs which have been developed. In this again, we have got different UAVs. One is micro or mini air vehicles in terms of quadcopters or quadrocopters. So AI is being used in terms of the training or different images from satellites to even the IR images in terms of the target detection, ranging, and identification. Apart from this, AI has got several capabilities in terms of tracking. Here, what is happening is in terms of the tracking, when a missile is actually attacking an enemy aircraft or so, it needs to be intelligently identifying the foe or friend aircraft. So therein again, AI plays a major role for identification of our own, aircrafts or missiles or any other targets in terms of the GPS locations are being aided through different technologies nowadays. And during its mid course or any other guidance, we the missile or any weapon has to take its autonomous decision in terms of the mission execution, whether to abort the mission or continue with changing its own course of target. And when it comes to autonomous ground vehicles, we have got several improvements and algorithms with respect to the tanks, identification of different obstacles in terms of, suppose, for example, I'll just give a scenario here. We have got a missile which is having a long range. It goes in terms of the cruise method, and this vehicle should be able to avoid all its enemy radars. So if you want to avoid an enemy radar, a missile has to fly at a very low altitude. So when we are flying at a very low altitude, the possible issues are like we many times we may not be able to get a GPS coverage. So during its course of the time, if my missile, which is trying to attack an enemy site or anything, so GPS is being denied, or GPS signal will not be there. So in that course of time, how I'm going to have this is a standby. We have a sensor which is on board. So that sensor is already trained with respect to the locations during its en route towards the target. So it identifies when GPS is not there, it shifts itself to the mode of the images and all those images will help and aid the missile towards its target. So this is one major application which is there nowadays in terms of the imaging capabilities, and this is going to help. Similar algorithms are going to help us in terms of the surveillance and reconnaissance missions. So gathering the enemy sites or changes in terms of the deployment scenarios, even during the war, we will be able to get an important data which is very crucial for planning a attack. One more major application is when we talk about the naval application. So we have got different scenarios here. So in terms of underwater navigation and exploration, we need to develop many what you say, sonar based technologies as well. Advanced, you can say, torpedo based threats and all these things are using nowadays different methods in terms of training as well. We this actually this area I'll not be able to tell you because most of the words which I am trying to talk on are on total classified information which I am not able to talk here. And in terms of maritime technologies, we are very advanced. All these projects, actually, many of these projects are actually secret, so I'll not be able to cover much in this area. And as I already told, like the future is again a different scenario in terms of enemies are going to have a based methods or having technologies to attack a country with its malware or spamware or any other, say you can say viruses or deadly based things to attack a banking system or even a government website or even a security sites at different places wherein they'll be able to jam or complete networking scenario or communication established setup. So this AI is going to help us in identifying all those kind of threats and then have our own programs to intelligently attack or even prevent from this kind of technologies. And when we say this kind of a risk, we have got a risk mitigated here with different AIs, and we have to do what kind of scenarios when we have advantages. So we need to have some kind of predictive analysis which will be able to help us in having different strategies with continuous monitoring and risk adaptation. And when it comes to AI in real-time threat, so all these radars and any other technologies in terms of communications, any other jamming technologies which are already there, have to be automated, and then we need to act very fast so that the enemy system is not going to destroy our communication systems as well in terms of the recovery from different malware attacks. So in terms of surveillance and reconnaissance, we have to have large volumes of data which have to be processed so that we'll be able to analyze this data and then use our intelligence systems for images as well. Introduction of you can say different algorithms. You can say with AI based tools and all, completely in terms of natural language processing as well the machine level intelligent tools. And when we talk about real-time processing, again, as I introduced to the radar systems and all, so we need to process the data from several radars which are deployed across the border, and then have communication set up so that this data is going to be process it and then have these anomalies, and then detecting patterns also is one more major area wherein we feed this our radars with different scenarios where it's able to identify the enemy mm, even satellite patterns as well. We are working even in terms of the satellite based you can say threats from different world, because nowadays even if enemy fires a missile which destroys one of our satellites, we are zero in terms of communication. So this is one major area. Even in India we are working on different satellites. Again, this is one more classified area which I'll not be able to cover on this. And when it comes to enhancing situation awareness, so we need to identify the enemy detections capabilities as well, how we are going to improve with respect to our decision making, whether to launch a different kind of missile, what kind of a target it is, whether we need to attack it right from behind or any other way, how it is, what is the methodology in which they are being followed, and then how we need to analyze in terms of the contextual analysis. So the third point is about the strategic applications of AI and defense. Here again, as I told you, one is on prediction. So what kind of a scenario, what kind of a missile it is, how the warhead is going to behave with respect to the destruction in terms of the okay, here I'll not be able to talk very much on this warheads also. But okay, utilizing historical data. So we have got different types of warhead like. So all these warheads are being analyzed with respect to the current and future scenarios, and we need to identify the current trends which is there in terms of the advancements at different countries, and accordingly we need to plan and then have our ammunitions in terms of our defense our ammunitions also. And one more area which is very important is in terms of a risk assessment when we have. So it is again hazardous to have this kind of a we can say warheads and all because they most of the things generate again the radiations and all, and how we have the contingency being planned to have such kind of systems being developed. And when it comes to war and war gaming and simulations, earlier scenarios were quite different. when it comes, like, we used to have certain ethical, let's say, war starting scenarios, where nowadays there is no such kind of a thing. Suddenly enemy attacks us, and then we have to be, ready in terms of attack, I mean, having defense, and then again attacking those things in terms of military strategies. So most of our things are being, analyzed by this national security team, and then coming out to have, such tactical weapons, which we will do, have our own technologies demonstrated, and training the team with respect to the world, real world scenarios, how the system have to be, operational in terms of the attacking as well defending. So all these things depends on our decision support systems, which we actually deploy across the borders. So these systems will have the communication technologies in terms of real time data analysis, as well attacking the command centers when we talk about a destruction of a communication centers, when we talk about the anti-generation radiation missiles. And the integration of all these technologies in terms of situation awareness is very challenging when it talks about the higher data rates, as well the data which is, coming from our own satellites, are being, diverted to different countries, wherein we will not be able to, identify that this particular data is coming from our own satellite or even any other satellite. So they are introducing in between, means some packets will be lost, or in some, unknown packets are being added into our own, data when it comes to wireless technologies and all. So this is one very very important area which has recently, started working on. And then in case if we are not able to identify, we will not be able to have decisions based on our own data, how this data is being, encrypted with different applications scenario. So one more, okay, other than our defense applications, when we talk about logistics and supply chain, so here, what is happening is, you can say, a e-commerce kind of a scenario, wherein, like, when we talk about the logistics and all. So suppose a user comes into picture with one of his needs, he'll be able to identify, certain things, and he is going to browse certain, parts or commodities and all. So that is going to identify, the area in which he is going to search all these things. So we have got certain automations developed in this. This is one of the highest application through demand, wherein all the, e-commerce sites are using this kind of technologies in supply chains with AI based management, as well warehousing and transportation of all these items. So this scenario is growing very faster, because business across the countries, across the, global scenarios is increasing in terms of its efficiency and operational costs. Earlier, we never imagined that we are able to, get such products to our home. So wherein this area is very, very, what you say, um rosy in terms of the business. And when it comes to the maintenance and military equipment, we use different sensors. Sensor developments are quite faster in terms of, you say, wireless technologies, then whatnot. Like, sensors are ranging from, seekers point of view, and to, you can say, saving power related areas, even wireless charging. And many of these equipment, when they fail, identifying the troubleshooting parts and all. Again, we have got different maintenance tools as well. Downtime. We are going to increase the downtime, and extending the lifespan of an equipment is again one more challenging task. In terms of our, defense equipment, we come across different radars, different, communication systems. We've got battery level radars. We've got, you can say, communication setups. And when we deploy this kind of a scenario, the cue from the missile is going to come from a radar, and this cue is going to help us in terms of the, you can say, uh, RF predictions, and even, you can say, spread spectrum areas, wherein, different, frequencies are being worked out in a single sensor. And when it comes to hyperspectral imaging and all, one more, which is a major area which, is going to help us in terms of night surveillance as well. The seeker is going to work even during day and night. And one more a major area in terms of the AI is one inventory management, which is very very, critical in terms of the management of all these, spare parts, or even for assembling a missile in terms of the launcher and the communication equipment, as well integrating this missile to the tank or any other armament deals. So this is going to be a very challenging task in terms of the management with several class of missiles as well as some class of weapon systems. So apart from this, okay, this has got a different application in business scenario also. How the system or the team is going to manage with respect to arrangements in terms of content based road driving and all. And the same thing is being utilized in terms of video database management and image database management. You can say when we talk about image or database, you can think of how YouTube is being managing all this old stock as well, the current stock. Can we imagine this kind of when we type any word, like for example you say news on so and so date, how this algorithms are going to work, and then pull out all the with the keywords and all. So this is one very interesting and challenging area in terms of inventory management when it comes to images or videos or even any other challenging stock or optimizing stock levels and analyzing the user requirements and keeping up to date with the latest trends and technologies. And when it comes to the human machine collaboration, you can say how we are going to impart intelligence to the soldiers. So what we are going to do is we have certain training programs which right from the beginning, from the design point of view as well, how to handle the weapon, how to intelligently change certain algorithms, or you can say even in real time we will be able to feed the data about the lat long, about the enemy targets as well, how to transport and even gather the decision making during the situations when it comes to critical. So how to change it during the real time scenario, how to identify the actual targets, etc., are being used. And we have got even this one of the laboratories in DRDO. This is called IRDE. So they are basically working on two different technologies. One is on bulletproof jackets, which are going to help this army. You can say the soldiers and all, with respect to threats from different bullets. We have got several developments which are happening in terms of bulletproof jackets, very lightweight, you can say, and very advanced materials which we are using. And apart from this, we also have a different nightwear goggles wherein it uses hyper you can say hyper sensors, wherein we are able to see through the dark, and we are able to identify different frequencies from NIR to LIR ranges. NIR is near infrared rays technologies, and LIR long infrared. So different uh, sensors are being developed by one of our laboratories. So this is going to help us for incorporating intelligence for different soldiers in the war scenarios, as well even for protecting our borders. The part two, which is having some kind of a training assistant programs, how to utilize all these latest gadgets as well, latest technologies which are presently in the market, how we are able to train and identifying certain new requirements when it comes to certain say automated equipment and all is really going to be challenging. And instead of having such scenarios at the borders and this surveillance, we will be able to train them using some virtual reality, you can say virtually with what is a augmented reality and uh, such kind of systems. And how we are able to even get the feedback whether to improve any other systems in terms of the tracking abilities, as well how he is able, how the soldier is going to work on the system, which is actually he is sitting in a simulation zone where he is going to get the actual feel that he is going to operate during the war scenario. So this kind of programs are you can say are also gaining popularity in terms of you can say training or simulations kind of a thing. The same thing is being used as spin-off for several gamings and other applications. And part three again, as I pointed out earlier, we are relying on different robots and technologies. Instead of humans, we are deploying robots for reconnaissance as well for surveillance missions. And these are going to help us in terms of highly safe for humans, and we can automate these systems for developing high risk applications and integrating all these robots for this logistics as well combat. So recently we have come across one of our threats at you can say one of the borders, so wherein there was a threat from one of the neighboring countries. So we have intelligently used a drone in terms of the logistics and combat, and even the same technology was used for one of our Himachal Pradesh border related area wherein there was a collapse of a mountain. So wherein some of our soldiers got stuck, and it was even done by a drone, wherein the drone has given intelligent data to the border security control unit. So then immediately one aircraft was sent, and then all these soldiers were recovered. So the fourth part again is the final part, which is on the challenges and ethical consideration, as Bhapi has pointed out. So here the data quality, when we talk about this kind of technology developments, how we are going to have the data quality as well the availability. Because when we talk about this kind of a huge data, how we are going to ensure that the data and the data sets which are being stored in our servers are going to be accessed very faster as well, be able to support this data driven means how we are able to address these databases, how we are going to intelligently organize index, and then present it to the you say intelligent algorithm which is going to analyze as well the um, address the faster requirements of accessing. So when we talk about this, the data quality has to be properly managed in terms of or can say storage as well the availability. When we talk about the gaps, how to minimize it. Otherwise, what happens is when even though the development point of view, we are able to achieve the data rates in case of server or any other communication, what is a network and all. So if it fails and we are able to retrieve, then suddenly the decision making capability of this particular scenario for a missile system or a network is going to come down. So apart from this, how we are going to ensure this availability in terms of you say MFFR or this kind of a scenario. So we have certain data engineers who are working on this kind of quality data sets. When we talk about the petaflops and other higher data rates. Apart from this, so how we are going to have the data privacy? For example, I've got a banking sector wherein many of the users don't want to have the disclosed about their data to any of our, what is a marketing guys or any other scenario. So how we are going to have this kind of data privacy concerns is one more major, area wherein one of our labs, which is working on this kind of a scenario. And when we talk about different algorithms which are intelligently using all this training data, the output accuracies, how we are going to analyze this data, whether my data is accurate in terms of you know and consistency when it is handling all these different kinds of scenarios, whether my data is correct or not, how we are going to utilize and how we are going to evaluate these algorithms in terms of the accuracies is one more very challenging and interesting topic. And one of our labs is also working on this kind of scenario. Managing algorithms with different biases and then errors, how we are going to attack, you say, the malware or any other viruses without this kind of a biased data outputs and errors is one more latest scenario. And apart from this, when we have different intelligence scenarios with streaming and communication devices, how are we going to ensure? Because my main server is giving me data at a different throughput, and my subsystems or a radar system is having it a lower data rates. How I'm going to down make or we can say reduce the data rates, and how I'm able to intelligently talk to the data rates when we have got some encryption and all. So again, security and scaling levels and all is one more challenging task here we are facing in terms of the communications when several systems are being introduced. So one more legal issue is in terms of moral implications when we have an applications in terms of autonomous thing, and here the moral implications. Many of the scenarios we can say we need to talk about the ethical scenarios in terms of autonomous weapons and ensuring compliance. So nowadays there is no standard organization in the world which is having some standard in terms of the laws when it comes to humanitarian grounds and all. So actually, I heard like recently one of our, I can say, some department is working on having some standards for working on this humanitarian laws and addressing resistance to different human military applications is also one more challenging task. So there is some board which is working. It is not from actually DRDO. It is from some other organization. Apart from this, how we are going to have these implications when it comes to legal issues and all. So there again, we need to have certain regulations and treaties. So in terms of international scenarios, all these things have to be worked out. We have got one actually group which is working on this. So it is called DISP. So it works with different countries. So they actually work with these treaties and any other regulatory authorities and all. So they actually prevent illegal proliferation and developments of these autonomous technologies and all. And when it comes to AI different decisions and all, how we are going to implement the transparent decisions in terms of monitoring and auditing systems. So India is actually thinking to have a separate autonomous auditing system. So when we have this kind of a illegal scenarios which are coming into the practice, and many of the data or any other things are being misused. Like we all heard about many data say threats in terms of protecting our own data as well. Different videos or images are being morphed up, and then many things are being heard about. So when we talk about the security concerns, how cyber attacks are being utilized. So apart from this, we need to work on potential attackers, how certain scenarios are there in the market. And when we talk about the security protocols, what kind of security protocols we have to follow. So we have got different frequencies in which we have got certain frequencies being allocated to defense. So how we are able to identify and then prevent the other private parties or private agencies not to indulge in such kind of frequencies and security protocols. So this is one more what you say challenging things we are facing nowadays. Many of our VHF or UHF communications, different protocols are there. Then again, satellite downranges, other than our own satellite receivers, we are able to have the breaches in our security and all. So monitoring constantly with the different anomalies, how whether my data is accurately being received with my receiver and all is is again a time-taking process in which we need to adapt certain encryption technologies which will provide prevent the this kind of a scenario in cyber attacks. And one more area is in this proliferation of these sensitive technologies and how we prevent these malicious threats in terms of software as well the hardware related issues in terms of the communication mismanagement and how to curb these misuses this how we are going to risk in terms of the threats is the challenging part. And apart from this, when you talk about the fault tolerance systems, how we come across unexpected operational disruptions in terms of communication failure or even in terms of communication failure as well, the stress testing system which are being put under threat from different air countries. For example, when we talk about an Air Force scenario, so here what is happening is the enemy is going to come up with a different warhead zone wherein it is going to destroy our own say the runway. So how we are going to address such kind of scenarios when such threats are being there, and how the system is going to work in terms of the disruptions. So this is one more important part which India is working on. to have a standby technology, to standby scenarios, how in terms of stress say step B procedure kind of things. And about the future look, so I think a previous speakers, many of professors or research organizations have spoken on quantum computing, wherein the impact of cryptography and the potential use of quantum algorithms in terms of faster solving problems and all, and the collaboration between the private sector and quantum research. So even DRDO nowadays, because of the government emphasis, we are having quite good amount of private sector, private industry is being coming into picture along with our defense. They are working in collaboration with our defense institutions. And coming into IoT and other sensors nowadays, we are working on two, three different projects with Army in the border levels at Jammu Kashmir, wherein we are working on a technology called real-time battlefield intelligence combining with AI and blockchain. So there is one project which is a huge project which is going on to have this terrorist infiltration. To avoid that, we have deployed some IoT sensors and all. So that is intelligently working with us. And apart from this, on robotics and advanced military operations, we are again working on four different places. One is for the Navy in terms of the sea intelligence, and apart from this, we are also working on different machine learning algorithms. The DRDO has got an emphasis to have AI-driven applications to have in each and every area, so that the development and the design process is going to have faster way of developing a product. And we are again working on adaptive learning for systems of different autonomous and different defense applications. So when we talk about strategic recommendations, the future is going to, we can say, the part of the defense, and which is having a cutting edge research in terms of the private sector as well. The government initiatives which we are following the right track to have a robust AI infrastructure. uh, all these trainings and models and different AI operations are being ensured with reliable software and hardware operation to support different AI applications. And we are even working out with an international collaboration for different, we say, global firms and ethical usage in terms of military applications, like the No First Go as well. Different. There is one more treaty which is being signed by India in terms of the responsible development and deployment of AI technologies. And we should have a long-term AI for defense. How we are going to have a roadmap in terms of technologies, seekers, radars, communications, you can say, and establishment of the underwater scenario as well for Air Force. As even for the next decade, the main challenging thing is in terms of the satellites, also protecting our own satellites and ensuring continuous evolution and implementation of AI strategies for different scenarios and areas. And how we are going to have the equipment as well the military personnel training in terms of its proficiency and developments of policies and frameworks is one more challenging and ethical for usage in terms of the warfare. And creating contingency plan for potentially related security threats is one more area in which our Department of National Security team is working on this, and we are able to meet certain strategies in terms of reconnaissance and then getting very good information to work on advanced technologies. And we can expect certain technologies which are again in terms of unmanned and air autonomous weapons, and anticipating all the cyber defense mechanisms is a more challenging and assisted decision making process. So thank you from my side now.
Okay, participants, if you are having any queries, you can please raise your hands and we will unmute you. Yes, sir, you are unmuted now.
Yeah. Good evening, sir.
Good evening.
Yes, sir. Actually, we are from the academic part of, we are coming from the different colleges, departments.
Okay. Okay.
So this is, I think this is a new topic for us. Actually, we know about the AI and AI applications, but the difference is the new things, sir.
Okay.
Okay, from your presentation, we catch a few points and we are unable to catch the few points also.
Okay.
What I'm expecting is this is a new area, no? Defense is the new area, so that better to use some pictures, sir, so that we can understand more concepts from the pictures. If you
Okay.
include your presentation, if you introduce the images, sir, so what happens in defense, so like that through images, if you explain, then we can. Otherwise, theoretically, you are saying so, but within a short period, we can't imagine the what happens inside. So that is the problem. Okay.
Sure. Actually, yeah, I sorry for that. Actually, Dr. Papia actually made me even spoke long back, but actually, last 10 days, I'm outstation. Actually, I'm in a mission. Actually,
Not
so I could not even complete my presentation. This is version one. I
Actually,
think.
sorry to interrupt you, sir. Just a minute. Sir, the participants were asking the query. Would like to clear that in defense areas, we are actually, it is not permissible to share pictures, even videos also in the public domain. So there are
not
some constraints, but still, sir agreed to the presentation. So because he wanted some insights in about the artificial intelligence in the defense domain
so.
also. So that is the reason. So this
No,
is one of the constraint that we cannot put a lot of pictures or lot of videos into it because
no,
there is
not
a lot of it's a defense system, so it has to
like
be taken care.
just a minute, madam. Aeronautical engineering course is there in academic part. Okay, we are not expecting the what are the happens in the real time pictures, ma'am. So for understanding the concepts, better to use the pictures. Through a pictures, they will explain what happens. Because aeronautical also comes under the defense. Okay, we are not asking the real time photos. For understanding of the concepts, so you are introducing the some pictures or small so in yesterday on presentation, they shown one video also. So like that, what happens within 1 hour we can't imagine what is going on, what is going on defense in defense. Okay, so that is my suggestion only. Okay, I'm
No,
not.
no,
It's
definitely, sir. No, no, it is no, no. Definitely, it's a point I've taken already because actually, in fact, I'm not happy with my presentation because certain things which I thought of incorporating in terms of what is it, the actual scenario, and I thought of showing some images as well, video also. Let me check in case if I have got some videos in my system which where I presented earlier.
okay. No,
I have presented somewhere, but let me see if it is there in my pen drive or so.
I understood your problem, sir.
Yeah, yeah. No, no.
But I,
There are certain videos which are there, which are actually made for public domain, which
actually,
we able to share that. But let me see whether I am able to show
not the issue.
some of the videos. Some videos or something I'll just show in case if you are able to see when I talked about air version. So this is one small clip which I'm going to play. This is the Astra missile. It's an air-to-air missile. You can see how it is being launched. Okay, so this is an anti-radiation missile. So which is you can say it is started from the aircraft. It is it is flying. So here what happens is a lot of technologies in terms of the launcher technologies, the seeker technologies are being okay looked about. So this is one secret project which I'm not supposed to show, but I'm showing it.
Okay, thank you very much, sir. Thank
Null. Okay, so
you.
this is one clip, just a short version. Well, just you can have a look. Hope you are able to see that, right?
Yes, sir. Yes, sir.
So this is when I saw this is you see this background scenario. You can see, this is we launched it at some place. So here, what happens is when we design and develop a missile, so this system has to work at extreme conditions, minus temperatures to even plus conditions and all. So when it comes to extreme temperatures, we need to launch and what is a test it at different altitudes, different work environments for the actual deployment as well for the actual training battle practice. So this we did it near, in you say Jammu Kashmir, in one of our you can say borders actually. So this is a target. So this is a main target. So this is short range, naval missile. Okay, so called
Okay.
NASMSR. And, this is anti-ship missile for short range. This is launched from helicopter, and then you can see the image, how the propulsion is fired here. I'm playing it back again. See how the dynamics of the missile in terms when it is released. This is one torpedo. This is one standalone anti-tank missile. This is a smart anti-airfield weapon. This is already into production for Indian Air Force. So the targets for this are the enemy, what you say, tarmacs as well, the runways. So which we deploy this for destroying the enemy runways so that they'll not be able to launch their fighter aircrafts.
Oh, excellent, sir.
This is our target. We have simulated our own target, how it is destroying that. So small part which I'm showing it. This is one hypersonic technology demonstrator vehicle, and this is an LRSAM, long range surface to air missile. This is Akash. This is surface to air missile. The range is around 35 kilometers. This is QRSAM. Again, quick reaction surface to air missile. This MP8 is a man portable anti tank missile, which I talked about initially in the IIT James part. This is NAG. This is BrahMos. In Astra. This is launched from Su-30, and the Serena is from ALH. This is our anti-ballistic missile program. This is a ULPGM. From a drone we launch a missile.
Oh,
So before that, we actually know this is our testing scenario. We are testing a propulsion system here. So we qualify the subsystems and propulsion systems here at our place, wherein we provide complete instrumentation how the designer is designing with respect to the actual predictions and the actual data when we compute. This is a scramjet engine basically. This is for our hypersonic technologies. It's a wind tunnel test. So we mimic these conditions. We have got several test facilities wherein we will be able to actually simulate those conditions. The motor of a long range surface to air missile. This is a pop out test. Hope you are able to see that, right?
okay, yes, sir, yes, sir, we get it.
Okay. These are all some land based flight trials. This is BrahMos missile, land to land. This is a target hit. I'll show you again. The quick reaction surface to air missile. So this is one nose cone suppression mechanism. This we captured at the frame rate of 10,000 frames per second. So each frame is around 1 microsecond. So all these systems now when we test them, so they happen in milli to microseconds. So this one stage separation. When we have a different missiles which have different stages. So we are doing a stage separation test here. How these two stages are separating here in the lab. This is a pop-out test. How the missile is coming out and the fins and wings are how unfolded and all. So this is a rotating detonation engine wherein the pulse is being spread across the surface of the muzzle. So certain things I will not be able to talk much, but
Okay.
this
Yes,
is
sir.
present.
Yeah.
This is present scenario where we are, the DRDO is and its capabilities.
Okay, thank you, sir. Thank you. Now we are very happy by seeing all this.
Certain things, we are our hands are tied.
No, no, no,
Because of
actually,
mission, actually, I thought of making a presentation still more interesting,
no,
but
no, no, sir. It
there are
is
limitations.
the topic and it means we'll feel some anxiety.
Yeah,
Sorry.
definitely, definitely. I hope I have some time. If I have some more videos, I'll just try to see or show some images.
Yes,
Still
sir.
more, I may be having in my PC.
Thank you, sir.
Yeah, this I'll show you. This is a missile called Rudram 2. This is launched from an aircraft called Su-30. So this is my own camera design, which I made it indigenously here. So it is going to capture the event. You can see that. So it is initially dropped down with the launcher mechanism, and after that, when it reaches around 8 seconds later, so the booster is fired. You can see the chase aircraft also there.
Okay, next query, Radhika Singla. I think you are unmuted. You can ask the question after this video.
Okay, I'll take a question, please.
Ms. Radhika Singla, I think you want to ask something. You raised your hand.
Probably she has to be unmuted, I believe. I think.
No, already done. Yes, you are unmuted. Radhika madam, you are unmuted. You can ask your question. Okay, any other queries from the audience?
Thank you, sir. Thank you for your presentation.
Welcome, sir.
Okay, Shubhadip sir, then continue the session.
Yeah.
Ma'am, I can share my number in case any of the audience have got still more doubts. I am happy to, get their doubts cleared. Or as well, I'll share something because we are actually DRDO is poised to having complete what I say interaction with the academia as well. We would like to invite them for many of our what say innovations and research problems actually. So we are happy to share our requirements as well in case somebody interested they really can work along with us. So we treat everyone as a partner actually in defense.
Yeah, sir. Please, you can share your contact number or email ID. We'll definitely give to the participants who are interested.
Sure, ma'am. Any other doubts I can.
Okay, I think we can continue with the session. Shubhadip sir, please continue.
Yeah, sure, ma'am. Thank you, sir. Thank you, Rohin sir, for your informative and inspiring lecture on this session. So, not to delay, let us continue. And now let me invite Dr. Satyabrata Sinha, the co-convener of this FDP, for his dynamic vote of thanks.
Good evening once again, everyone. It is my privilege to extend our heartfelt vote of thanks to our esteemed speaker, Mr. Rohin Koduri sir, scientist at TRDL, for delivering an exceptional and inspiring session on leveraging AI for defense, modern defense innovations and strategic applications. We are especially grateful for the effort you took to showcase videos for the of the latest technology that is being developed in India. In spite of being, I mean, very tiring maybe and traveling journey.
So you need to see the assessment test, and the assessment test will be conducted on the last day of the FDP after the valedictory session. So more guidelines will be providing you just on the day of the test also. And it is advisable to take the test through laptop or computer because there are some restrictions. So you cannot switch the browser while taking the test and you have to complete it within a single go. So the test will be MCQ based and it will have 30 questions. No negative marking is there. And total time duration given is 45 minutes. So in your dashboard, the link of the test will appear when the test is active. So you can go for the test at the last day after the valedictory session. If any participant is having any query, you can raise your hand. Yes, you can ask Mr. Divyang. You are unmuted now. You can post your query.
Yeah, actually, ma'am, I have to carry that. I am attending the sessions regularly, but on the first day, the first session will be with the different name, and right now I'm doing with the Atal register name. Still, yesterday I also do with that the same name. Today I have that
Okay,
in
okay.
register
No
in Atal,
problem,
but
sir. We
still
are
highlighted it.
I understand. No problem. We have posted one sheet for us attendance, so you can check with that. In case your name is highlighted, you can post a message or mail. We will check it and correct it accordingly. Okay.
Yeah, thank you, ma'am.
Miss P. Janki, you want to say something? Yes, you are unmuted. Miss P. Janki, want to ask something? Yeah, please ask your question. Okay, some more questions are coming. Fine. Yes, Dr. S. Vijaya, you want to ask something?
Yeah, good evening, ma'am.
Yeah, good evening.
Ma'am, you have posted a YouTube link recordings. Will you
Yes,
share
ma'am.
the PPTs at the end, ma'am?
Yeah, sure. We'll give
Yeah.
you the presentations PPT also in the group. Okay.
Okay.
I hope you are there in the group, right? So you'll get it.
Yeah, ma'am.
Yes, definitely.
Yeah, thank you.
Okay, I think anything you want to ask Dr. S. Vijaya, you have completed, right? So our guest, next resource person has already arrived and we want to start the session. So Mr. Shubhadeep Goswami sir, please continue with the session.
Sure, ma'am. Okay, so good evening, Dr. Abhinav Kumar sir from IIT Hyderabad. Let's welcome him for our second session today. Quantum computing and artificial intelligence are poised to transform next-gen communication networks by addressing limitations in speed, efficiency, and security. So now let's have an interactive session on role of quantum computing and AI in next-gen communication networks. But before that, let us know about Dr. Abhinav from our convener, Dr. Papia Dutta ma'am.
Yeah, Dr. We welcome Dr. Abhinav Kumar sir on the dais today. And Dr. Abhinav Kumar sir received the BTech degree in electrical engineering, MTech degree in information and communication technology, and PhD degree in electrical engineering from IIT Delhi in 2009 and 2013, respectively. From September to November 2013, he was a research associate in IIT Delhi. From 2013 to November 2014, he was a postdoctoral fellow at the University of Waterloo, Canada. Since November 2014, he has been with IIT Hyderabad, India. Currently, he is serving as a professor. His research interests are in the different aspects of wireless communication and networking, including machine learning, IoT, and 6G communication. So we welcome Dr. Abhinav Kumar sir. Please continue with the session.
Sure. Thank you. Thank you, Dr. Papia. I hope I'm audible. And
yes, sir, you're audible.
Great. Thank you for the kind introduction. And I have been previously also participating in similar talks organized by Professor Papia. So thank you for inviting me for this particular session. And let me quickly check with my slides if they are visible. Please do let me know if you can see the slides.
Yes, sir, it's visible.
Okay, excellent. Maybe in interest of bandwidth, I will see if I can switch off the camera. Okay, great. So at any point of time, if I am not audible, if the slides are not moving, please do let me know or please call me. For this particular session, we are going to discuss about role of quantum computing and AI in next generation communication networks. In this context, this is 6G that we are talking about now. 5G already is available in the market. You can buy a handset and services are also available from various operators. Coming to a brief outline of my talk, I'm going to start because we are having three very distinct topics that I'm trying to cover. It's very difficult to cover all three together, but I will give it a shot. I'll try my level best to give you an overview of how the three are going to marinate as we move forwards toward, forward towards 6G. So there, what I will start with is maybe first I'll try to give you an overview of how quantum and machine learning are going to come together. And then various applications of quantum in the context of 6G. Then I'll pick certain use cases from, for example, security perspective, give you an overview of 6G also for those of you who are not familiar with 6G in particular, and then try to again go into details of couple of use cases. For example, security is one, IoT is another, digital twin is another. And in those technology or use cases, how does quantum and machine learning plays a role? And then finally, I'll try to summarize all of it together, stitch it together to maybe revisit, the thought that we started the talk with, which is how does what is the role of quantum and AI in the context of next generation 6G networks? So at any point of time, if you have a doubt, if you have any comments or query, feel free to unmute and ask, or please feel free to type in the chat window. We can also have a discussion at the end. I'm planning like 2/3 talk, 1/3 discussion kind of distribution over time. So maybe coming to the very initial part, which is about the two key topics of quantum and machine learning. Please note, machine learning now has been around for a while. And there are several applications that have been already available in the market. All of you are familiar with ChatGPT and LLMs or large language models, which a lot of folks are now using both for personal as well as professional use. So that way, machine learning as a technology is maturing very fast, is finding a lot of use cases in the market. Quantum, on the other hand, is a developing technology. Quantum computing in particular, it's not so widely available. It's mostly in the research domain. But then if you look at machine learning, quantum, and optimization, at the intersection of these three is where a lot of activity is going to happen in the next decade, where in the context of optimization techniques, already people are designing intelligent algorithms, which is using machine learning to solve optimization problems. So in past 5 to 10 years, a lot of research in 5G and beyond communications has happened on optimizing various network parameters, various network algorithms using various machine learning or deep learning, including in our own group also. But in interest of time, I'm not going to go into details of our own work, but if somebody is interested, I'll be happy to connect and share more details at a later stage. So that is where, so the machine learning and optimization is a sphere, or the intersection of this intelligent algorithm is something that is already well explored. In terms of quantum and optimization, there is a lot of work which is happening in quantum information processing, which is a lot of it is theoretical in nature, where people have tried to see how we can best utilize, let's say, the qubit representation to solve various types of optimization techniques, and what are the kind of performance or theoretical results that can be derived on top. So there is a class of literature available in that direction also. But at the intersection of all three is where now a lot of interesting work is happening in terms of quantum machine learning, where we try to use quantum computing to solve large scale machine learning problems, to try to optimize, let's say in our context, because we're talking about beyond 5G or 6G networks, to try to optimize these networks. So how can we utilize this enhanced computing facility or resource that we have in terms of quantum, use the existing know-how of machine learning, combine the two to create a quantum machine learning setup, and then use these to solve various optimization problems. So that is the very broad level view in terms of how things are evolving. And towards the end of the talk, I'll try to converge this into various use cases, where scenarios where we can apply this and how to apply these together. So with that as the context of today's discussion, let us quickly jump into the details of, let's say, quantum and ML. This would be very similar to, so as part of the talk, I'm presuming some of you are familiar with machine learning parts. I'm not going to go into the basics of machine learning, but if there is not a lot of awareness, I can revisit. I have another set of slides. I can use that and maybe give you a primer also if required. So in terms of quantum and machine learning, please note a typical machine learning model. This is a typical ML flow. So if you remove the quantum part out of this block diagram, any machine learning algorithm, you typically have, especially the supervised learning algorithms, for example, you will have, let's say, a training data set. You will apply some pre-processing technique on top on the data. Then you will train a machine learning model. Given that machine learning model, now you can use this model on test data set to solve some real world problems. Right? That's a typical flow of any ML model, or even a DL model for that matter, right? Now, in the context of quantum, the enhancement is in terms of processing. So if you have a very large data set, which if you're representing it in binary, the data set size is huge, and it is not possible for the current hardware to process such large size data set in a reasonable amount of time. This is a challenge that can be solved using quantum, because now with quantum, what you're saying is we are not going to use bit representation. We are going to use qubit representation. So we can have significantly larger number of states represented in the same qubit, and then we can parallelize the processing. So we can take a large, humongous amount of data, process it using quantum processing, and then train quantum machine learning models, which are models designed for, let's say, the qubit representation and not the binary representation that the current state-of-the-art ML models are used for or are represented in. And then the advantages in terms of complexity. So now we don't have that much constraint in terms of time, and hopefully in terms of cost, because cost currently it is not a right parameter to compare, because we don't have commercially available quantum computers, right? We have normal binary representation based typical digital computers, if I can call them. So Alternatively, at some point, once commercial products are available, we can also do a comparison in terms of cost. But at this point of time, the comparison can only be in terms of time. So the time taken by a quantum machine is going to be significantly lower than an equivalent digital machine. And that is where the gain is going to come from, because we are going to parallelize the representation. We are going to process it at a much faster rate. And then we can deploy it, for example, for 6G use cases or communication models, which current digital communication, computing models are not able to solve. So already we are touching the limits in some sense. So if you look at the ML-based approach, the traditional ML-based approach that has been used in 5G and beyond networks, we are already reaching the limits of compute, for example. If you want to deploy an ML-based model for a very diverse, heterogeneous 5G network environment also, sometimes we are reaching these limits where we need an access to cloud. And then the challenge comes into the picture that if you have access to the cloud, then latency comes into picture, because you have to offload the data to the cloud, and then you have to train something in the cloud, use the trained model in the cloud, predict something, and then utilize it in the context of your regular setup. So that is one aspect where quantum based compute models, if and quantum based compute resources, if they're available, they can significantly reduce this time factor. That is going to be one key differentiating factor between quantum machine learning and traditional machine learning models, both in terms of training as well as in terms of test or prediction time taken. If we dig a bit deeper into this, this is just a slightly more inside view where, please note, this is the classical part, because even though we are talking about quantum computing, the data that is being collected is from a classical approach, a digital data. So if you have camera data or if you have sensor data of any kind, let's say images, for example, in this particular representation, these images are binary images. They can be colored, but still binary representations, right? So we have these classical parts which are training images in terms of or binary representation, or test images in terms of binary representation, where we can use classical approaches to extract out features and then feed these feature vectors itself to the quantum representation. That is one approach that can be taken, where for the training set, you extract out the features, feed the feature vector to a quantum representation, prepare a quantum state, pass it on to this feature quantum state to a quantum computing device, which, using the, let's say, distance-based approach, it searches all the k distances and gives a certain measure which can be used to take an output of k image indexes, and then based on majority logic we can come up with an output, right, in terms of classification. And the advantage is here, all of these can be parallelized in some sense. We don't have to feed one at a time. We can have a very large size feature vector also, and it can be parallelly processed across the vector state, because it's not a digital representation anymore, it's a quantum representation. So that's one key feature or one key enhancement that we foresee by marinating quantum and machine learning. But the challenge lies in, for example, efficient feature vector representation itself. Like, what is a good feature vector representation we should be taking in? Is brute force good enough, or should we further optimize the intersection part? So what you see in terms of the dashed lines is where a lot of research is going to happen on how to combine the two, the classical approach of machine learning and the quantum representation part in terms of the compute or processing. So that is where I foresee a lot of research happening. Now, so this was the first part, just to give you an overview of quantum and machine learning. Now coming to quantum in 6G. So this is not necessarily with machine learning. This is quantum in general, because you can have quantum computing and it can be used for various use cases. One of them, as you see in this representation in AP3, is quantum machine learning also. But that's not the only place where we can use quantum technologies. For that matter, as shown by Mohammed and others in this work, there are several applications potentially in 6G itself where we can apply different quantum technologies. And these can be in terms of, for example, the most prominent one is in terms of security. And I have other slides going into detailed aspects of those security features also. But one is, for example, quantum key distribution, where we can look at a QKD based approach for enhanced security. Alternatively, we can apply quantum machine learning to enhance certain aspects in the network itself. We can also use quantum sensors, and this is where the differentiating factor comes in terms of what I was mentioning here. So this is the classical approach where the sensors are classical sensors, like say image sensor, camera, which are collecting data in a classical representation. Can we design sensors itself, which are, let's say, quantum sensors, where we are trying to collect the data directly in a representation which can be fed into a quantum state, right? That is another key area in 6G. Also quantum based error correction. So far, because the data representation is digital in nature, we are using these binary codes, error correcting codes, which are used in the communication channel to enhance performance, to increase reliability. Now with quantum, can we design, and if the representation itself is possible in a quantum domain, for quantum based communication, can we use or can we design better error correcting codes directly in the quantum representation itself, instead of using a binary error correcting code, which might be a suboptimal approach if you are going to use quantum communication. Also, in terms of random number generation itself, how can we further, because now, please note, we are not talking about binary or digital information. We are talking about qubit representation. So now if you're using qubit representation, what is the analogous of a random number generation in a qubit representation? Because now we don't have one number. It's not like digit 1, digit 2. Now we have a full gamut of representation possible using one qubit. So now using this qubit, how do I generate random numbers in the domain of qubits? Right, and then once we have these, can we use these to enhance the cryptography? So let's say we have done quantum key distribution, quantum key generation, or quantum random number generation for quantum key generation. Then how do we use these in the context of cryptography to enhance security for existing infrastructure? And then, as I mentioned earlier, given the compute part, how can we use the quantum computing at the edge? And again, this is slightly futuristic. Maybe 6G will come before we have quantum computing at the edge, because 6G as a technology is maturing fast. There are certain aspects of 6G, as I'll be presenting in subsequent slides, which are already materialized in terms of commercially available hardware. But the quantum compute part is something which may take certain amount of time. So I'm not very confident whether the 6G timeline and the quantum compute timeline in terms of commercialization will be having a lot of overlap. My gut feeling is 6G will come first with certain representation, certain use cases demonstrated using quantum, but most likely quantum will mature a bit later. But that's my gut feeling, and I can be really wrong. Maybe the converse will happen. Then we'll have to wait and we'll have to see how the two technologies evolve. And that is the beauty of research, right? You never know which of them, based on global research, which one moves faster and at what pace. So that is something for all of us to see as we go forward. We can also apply this in the context of data network management, where we can use both quantum as well as machine learning for advanced data processing, for better resource interference management, for better signal processing, for designing and planning the network, and even using in physical layer the advanced modulation schemes. Right. So this is again an application of quantum in various aspects in 6G. Now coming to specific applications. For example, one very specific application for quantum is in the context of security, and within security we are looking at quantum key distribution. So now if you have QKD, which is quantum key distribution, how can we use it, for example, to ensure semantic information communication? Now, what do we mean by semantic information communication? So for example, let's say we have certain sort of devices. In this example, we have, let's say, cameras. There are certain cameras available at the semantic layer. There is certain amount of information they're generating in terms of videos, for example, and there is some semantic information attached to it also in the context, what context they're collecting the information for. Now this layer can be running on top of a QKD management and control layer, where there is a QKD controller and a QKD manager, and these QKD controller and managers are using these quantum keys, the secret keys, which is running on top of this QKD layer, which is being exchanged onto these various nodes, or which are being used across these various nodes to ensure security, right? So we have a QKD layer for security, a QKD management and control layer running on top to decide how keys should be supplied, how keys should be managed. And then on top of these, once security has been established, we are trying to send semantic information through the semantic layer to ensure it is quantum encrypted using the QKDs that have been distributed in the network. So as you see here, we can have sort of handshake and configure the QKD nodes using the controller. and the manager based on the requirement of the semantic layer as to what data should flow from which device to which from which host to which host. So in this example, for example, there are two cameras. They're trying to send maybe send and receive pictures to this virtual service operator. So then between these nodes, we need to ensure the encryption. So suitable key exchange has to happen in the quantum domain. So there is again a very important aspect because it is slightly atypical compared to a typical key exchange that happens. For example, the digital key exchange is relatively easier to implement. But how do now we ensure QKD based, or quantum key based distribution to ensure security or encryption of semantic information, communicated over the network? Where again, to enable this, we need some sort of a decision-making framework where the decision-making framework helps us in figuring out what should be the resource allocation, how the resources should be used in terms of their costs. So we can have some Shapley value-based cost calculation, and then how to share this across a coalition, how to distribute it across various nodes which are part of the network. Maybe to give this more meaning in terms of a real world example, this is a use case for maritime surveillance where we are saying, let's say we have multiple devices which are taking pictures next to some ports or next to sea or lake. And these pictures have certain semantic information also available. For example, here we have semantic segmentation module, which is creating these pictures, separate pictures of boats. So from edge device 1, we have different boats, right? And similarly from edge device 2, we have different boats. And now we want to do certain sort of comparison between the interest of virtual service operator and figure out how to process this semantic data. That is where the quantum part, key distribution part comes into picture to enable secure communication between these edge nodes and the virtual service operators. We can also have the quantum compute part running, which on top of which these virtual service operators might be running. So that is another aspect, but that's another work in itself, maybe. So that's one example. And maybe coming to, because I wanted to cover all three and the intersection of the three. So maybe a brief overview of 6G itself. So far what we have discussed is we have discussed quantum machine learning. We have looked at application of quantum in the context of 6G. And there we have looked at quantum key distribution and semantic information flow. Now coming to various 6G scenarios, because this would also help us as we go towards the end of the slide. This will also help us appreciate how the intersection of three is really important as we go forward for the ecosystem. From a 6G scenario perspective, we are looking at the following. We are looking at so the term they're using is extremely reliable low latency communication, or ERLLC. This can be, for example, fully automated driving. There is a use case, or industrial IoT. I have a couple of slides highlighting those industrial IoT aspects later. We can also look at mobility in terms of deep sea sightseeing, in terms of space travel. We can have Internet of Everything, machine type communication, Internet of Bionano things. And also AR, VR, holographic vertical, and tactical and haptic internet. And these are certain scenarios where 6G is going to be providing the differentiating factor compared to 5G, right? And what are the kind of capabilities we are looking at? So as per IMT 2030 report on 6G, we are looking at user experience data rates of gigabits per second. Spectrum efficiency, which is 5x compared to, let's say, the current 5G deployment. Mobility support up to 1,000 km per hour. So essentially for aerial communication also, we should be able to support through ground station based, UAV, or even for normal human based communication also, which is for somebody flying in an aircraft at a low altitude, can be supported from a ground station. And latencies, we are looking at 0.01 to 0.1. So there is an order of magnitude reduction from 5G. So please note these figures on the red curve are the 5G figures. So and as you go out, the network is changing. So for example, this was 5G figure for latency, which was 1 millisecond, and now we are targeting 0.01 or 0.1 millisecond in the context of 6G. Similarly, connectivity density, which is number of devices supported, we are looking at an exponential or 10 times increase. So earlier we are looking at a million devices in 5G, and now we're looking at 10 million devices in the context of 6G. Similarly, 100 times network efficiency in terms of energy, a 10 times increase in area traffic in terms of gigabit per second per meter square, and a peak data rate of terabits per second. This is more from the network side, but from a user side, most likely we'll look at gigabit per second, right? So with these at the 60 capabilities, now let us revisit the question of how quantum and machine learning are going to enable these capabilities. So there several technologies are already being championed in the context of 5G and beyond. One of them is, for example, network slicing. Network slicing is a known technology in the context of 5G. It is already available, where if you have a radio access network, then we can use a cloud network to create different network slices, and these slices or the cloud slices will serve different types of users. For example, each slice might be running optimized for a certain type or aspect of user. Right. So this is an existing technology. Network slicing is an existing technology in the context of 5G and beyond networks. But now in the context of 6G, we want to marinate this with quantum. And what we want to do is we want to utilize the quantum computing instead of, let's say, just a GPU based or GPU accelerated AI algorithm running at the edge or near the base stations. Can we use the quantum computing based approach to enhance the compute and enhance the quality of experience for the users, both from the edge node perspective as well as from the core network perspective, right? So that is one key area where I foresee quantum computing making a lot of difference, because one of the bottlenecks faced in 5G has been that if we are running various network slices in the cloud, the latency becomes an issue because the cloud connects to your access network and the access network connects to the user equipment of the phones. So there are these multiple hops involved, and when you are running these layers or slices in the cloud, for certain layers, given the latency concern, for example, automated driving, completely automated driving, there we need to ensure, let's say, latency of less than 0.1 millisecond. Otherwise, it's equivalent to like it can cause accidents, for example. But current networks are not able to provide it because the compute is available in the cloud, and the latency becomes a bottleneck. Now, can we have certain computing resources, let's say quantum computing resources, which can minimize this latency if they are available closer to the base station? And then that essentially ensures, and which is what fog node are all about, right? So in some sense, it's like a quantum fog node, if I can call it. So which is how we are potentially going to cater to some of these use cases that I mentioned, which current compute hardware are not able to meet these requirements in some cases. Similar to this, we can generalize this further. We can also have a 6G IoT framework for, let's say, sustainable smart cities, where again, from an IoT framework perspective, please note these layers are traditional layers. So you can have a sensing layer, you can have a networking layer, you can have a communication layer, a compute layer on top, a data processing layer, an application layer, and a business layer, where you have certain business model which is running on top of these application layer, let's say for connected intelligent smart cities. And then you have a lot of data processing layer, which is processing the data, including data analytics, decision making. Now this is one layer in the IoT framework, the data processing layer, where quantum computing will make a lot of impact, because currently, again, similar to the previous example of 6G UE based or database communication for the mobile nodes, for IoT nodes also, because a lot of this compute is centralized in the cloud, the latency becomes a bottleneck. Also, compute is not very cheap. So if you look at compute for a limited amount of resources required, a lot of vendors might be giving it for free or subsidized. But the moment you start scaling it, the moment you start saying, okay, in my IoT network, I will have 1 million nodes. In my IoT network, I will have 100 million nodes. Then the costs escalate a lot because of the compute involved. So one aspect where quantum is going to make a lot of impact is if we can ensure lower cost compute through quantum computing, then there is a higher chance it will be adopted, let's say, in a 6G IoT kind of a framework, because then it can replace a traditional compute, high performance computing or traditional computing technology that is being used in the data processing layer. and it can augment and ensure faster deployment of a 6G IoT framework. That is one. Another one is in the context of communication itself, because we can have communication also in the representation itself can be in terms of quantum, let's say qubits and all, right? So now the communication layer and the data processing layer are the two layers where I see impact of quantum as we go forward. And both these layers also have an impact from the machine learning perspective. And that is why today's session, which is like combining the three together. Right. We can also have this in network and sensing layer, but maybe in interest of time, I will not go into those details because I have a couple of other things that I want to cover as part of this discussion. So again, giving you certain trends from 6G perspective, we already have AI to a certain extent in 5G networks also. You can deploy certain nodes, certain modules in the core network, which are ML based modules, but they are mostly parallel modules. They're not core components of the current 5G network. But in the context of 6G, what we're looking at is if you have a UE, which is the phone, connecting to a base station, which is your tower, connecting to your core network, and which is connecting to an application server running different kind of applications, you can have local AI running at each of these nodes. So you can have an AI module running at the phone, you can have an AI module running at the base station, something running in the core, something running for the application server. And then to optimize cross-layer communication, you can have joint AI between UE and base station, between core and application server, and we can even have end-to-end AI. Right? You can view this more from a communication side where you have physical layer communication between UE and the base station. You can have a MAC layer based communication between UE, base station, and core. And you can have an end-to-end networking layer based communication between UE, base station, core, and application server, right? So a TCP IP based connection. So now we are trying to optimize them and use AI in the context of optimizing each of those layers in some sense. And that is why local, joint, and end-to-end AI, right? We are also looking at opening up the network in terms of how can we use open source RAN, open source networking elements itself, and then connect a very large number of devices to this network. So massively connected machines and robots. But this kind of trends comes up with a challenge, which is in terms of security. And that is where quantum is one of the key technologies that is being discussed. So there are a lot of possibilities of security threats now in the context of 6G, because now we can have at each of these intersections or interfaces. Please note, from a security perspective, larger the number of interfaces involved, higher the chances of a vulnerability in any of those interfaces. Because at the end of the day, a vulnerability comes into picture because if there is an interface, if there is only one phone which is not communicating with anything, if you're just switching off the network and playing a game on it, highly unlikely it will get a virus. The issues come into picture when you connect it to the network, when you create these interfaces. So larger the interfaces, more the issues, right? And now we have several such interfaces because now we have these virtual RANs or the ORANs running on hypervisors, which are being, in some sense, a virtualization layer running on top of the actual physical hardware, which is the CPU and the GPUs. And now we have created these additional interfaces where we can have issues, for example, let's say user privacy, unauthorized access, or a denial of service attack happening over these multiple types of devices which are connected to the network. Because they're using open source content, and this has been mandated also in some sense in 3GPP is being discussed that a lot of content should be, as much content should be open source as possible, but then open source code comes with open source vulnerabilities because the code is now available in the public domain, so anybody can figure out a vulnerability, and not all folks working in this domain in security are nice folks, right? So some of them may exploit the vulnerabilities without reporting them. Also, we can have various kinds of conflicts and collisions happening, or we can have issues in terms of the virtualization security itself. So because you have a hypervisor layer running to create the virtualization between these VRAN, ORAN, and the actual hardware, we can have security issues with the virtualization layer itself. We can also have issues in terms of the adversarial machine learning. So if we have a virtual core running trying to optimize the network, can we create data which is being fed into the network, custom data, which is adversarial data, which will force the ML model running in these cores to behave in a manner which is not expected out of them, right? So that is the kind of security challenges we are looking at, and which is where we have different kind of solutions that people are looking at. But for us, So in terms of network openness, we can have different kind of security threats like unauthorized access, machines with low security, like the IoT devices connecting and all, unauthorized access and open interfaces, software collision and all, right? So, and solutions are like using using PKIs and zero trust architecture, using secure governance system, identification and authentication management, and conflict migration, right? So there are several such issues in terms of threats and solutions. One of the key issues is with respect to quantum computing itself, because please note, given the significant amount of compute potentially possible through quantum computing, the asymmetric key algorithms that are currently being used, they may become all of a sudden unsecure asymmetric key algorithms, because current asymmetric key algorithm works with the principle that you have, let's say, a public key and a private key. I am using the public key to encode my data, encrypt the data, and then I am communicating with the network, and then I'm somehow communicating the private key to the receiver. The receiver is using the private key to decode the data or decrypt the data. But this works under the assumption that others are not able to decrypt, because the computational cost of decrypting public key encrypted data is humongous. Like you will need a supercomputer to decode something which is like a reasonable size data chunk itself, and larger key sizes for such scenario, for asymmetric key scenario, more and more difficult it gets with the current hardware, with the current compute. But with quantum computing, the issue is, and there is a lot of work which has happened in this domain for quantum compute based security challenges in terms of state-of-the-art key algorithms and their potential vulnerabilities. So where now we might not be able to maintain this asymmetric key algorithms securely. It may become unsecure all of a sudden. The compute required, which was humongous earlier, with quantum compute, maybe it is possible to break the encryption within few seconds or few minutes. So then we have to figure out post-quantum cryptography, and which is where, for example, the previous slide, if you recall, the QKD, quantum key distribution and all comes into picture, because now we can't use the traditional key-based algorithms. We need to design post-quantum cryptography and use them for 6G security. So that's one of the key challenges, and which is why there is kind of this race happening between 6G and quantum, right? Based on whichever technology matures first. Accordingly, we'll have to figure out how to use the other one in its context. And so highlighting it a bit more. So as I mentioned, quantum and 6G security is one of the key aspects when you look at the two together. And there, please note, in the context of 6G, we can use quantum for quantum assisted communication or quantum communication. We can use it for quantum computing. We can use it in the context of security. We can also use it for quantum machine learning algorithms, right, which I have explained in the beginning of my presentation. Where quantum security in itself can have aspects like post-quantum safe cryptography, quantum resistant networking hardware, where current hardware may not be resistant, networking hardware may not be resistant to quantum compute-based devices. So can we create quantum resistant networking hardware? How do we perform quantum key distribution, QKD itself? And then what are the quantum-based attacks possible? Like if you have cloning attack, collision attacks, how do we mitigate them, assuming both the attacker and the service provider have access to quantum computing facility? Also, so this was at the intersection of quantum and 6G security. We also can look at it from the purview of AI and 6G security, because please note, we can have AI for security in 6G, where we can have various machine learning algorithms, and these can be quantum machine learning algorithms also, right? Where we use these machine learning algorithms for autonomous systems, for federated learning, for deep learning, for privacy preserving machine learning to enhance the security in 6G. At the same time, we need to also ensure security for the AI itself. How do we ensure trustworthiness? If you are running a model, how do we know that this model can be trusted? The outcome of this classification or this prediction algorithm can be trusted. What are the ethics and the liabilities for such an algorithm? In particular, for autonomous systems, for example, if you have an autonomous car, whose liability is it if a machine learning model in the autonomous car fails and it causes an accident? Also, in terms of the model and the data resilience, because let's say the car has been trained with the data set of, let's say, video data set, for example, for autonomous navigation or autonomous driving, using a data set in a North American city. Now we are trying to drive the same car autonomously in an Indian city. So the data changes, right? So now can we create adversarial representations which can cause this car to abruptly stop or cause this car to maybe collide with some entity. So their adversarial AI is another thing which people are looking at. So from a security for AI itself perspective, people would like to know what is the current explainability of the AI model involved, what kind of scalability is possible, and what is the visibility available for these models to ensure 6G security with AI. So, and then we can also look at not only security, we can also look at privacy. So we can have AI, quantum, and 6G, and look at various types of various notions of privacy. Because please note, there is so much amount of data already available in the network. You look at any entity, for example, any person. We have our mobile phone. That data is available. We are wearing these health bands so that personal behavioral data is also available. There are cameras deployed inside the house, inside the office compounds, and also there is this image data available. Whatever communication we are doing using the mobile phone or the laptop, real time, that data is available. Our location data is available. So from a privacy perspective, all sort of data that is possible for most of us, it is currently being available, right? It's currently already available in the cloud with our service network providers. And now on top of this, we can run various AI ML algorithms to do various prediction or, it's not that we will do it. It's already happening. The operators are already doing this. And that is why you must have seen that a lot of times you're saying something, you're discussing something, and all of a sudden your phone starts showing ads pertaining to what you're discussing. Right. So those kind of challenges are already come into picture. And there again, we can look at the ethics part and the liability part also. So now how do we use, and based on this, there can be serious privacy violations if somebody is eavesdropping, if we can predict the behavior, location, position of a person or an object, and we can classify user behavior and use that to maybe sell something or cause adverse actions for a particular user. So now we want to ensure this privacy protection. We want to make sure, let's say, can we use differential privacy? Can we ensure homomorphic encryption? Can we have privacy by design in the network? And that is where quantum computing again comes into picture, because with the current state-of-the-art privacy preserving technology, marinating it with our communication technology with 5G and running it runtime is becoming a challenge. So I think that is where again I foresee quantum playing a role by enabling various privacy protecting mechanisms as a built-in, as a privacy by design in the network itself to ensure privacy of these various kinds illustrated. And so so then coming to the intersection of the three, because we started our discussion with the AI and quantum, then we looked at quantum and 6G, we also looked at AI and 6G to a certain extent. But now if you have to combine the three, how do we do that, and what is going to be the network like, with AI and quantum involved? So there again, please note, it's going to cover the full spectrum, where in terms of the deployment, if you look at the current deployment for 4G and 5G, it's mostly land-based deployment. But now in the context of 6G, we are looking at air. So we are looking at air to ground, ground to air communication using 6G. We are also looking at UAV or app-based communication with the ground, where they might be used for network extension as shown here, where you have a fluid cell, where based on the requirement, we can deploy a UAV and it can provide coverage to a particular UE beyond the coverage of regular base stations deployed in the network. We can also look at communication between vehicles, for example, vehicle to vehicle communication, from not only land but also in water, not only on water, within water, underwater also. So we are now potentially looking at use cases like ship to air communication, ship to ship, ship to ground, ship to submarine, right? And all of these are use cases that are currently actively being discussed as part of the 6G specifications that are coming up. Not only land, air, water, we are also targeting space now. Can we use satellites, for example, satellite to ground communication, satellite to air communication? How do we enable all of these in the upcoming 6G network, right? So those are the kind of deployment scenarios we are looking at. In terms of the interfaces, we have interfaces in terms of the user side, interface in the air as a wireless technology, at the edge, at the network infrastructure. In terms of the layers running on in these deployments for these various interfaces, we'll have, but of course, a physical layer, a data link layer, a presentation layer, network layer, and an application layer running on top. And across this spectrum, we can have machine learning at each of the interfaces. And we can use quantum as a technology to enable such a large scale deployment. Please also note, because if you look at this, this is we have only looked at deployment scenarios in terms of where we are deploying, what kind of interfaces we are covering, what kind of layers we are covering. But we can also have something at the scale of, let's say, wearables. We can have sensors deployed on the human body, and then these sensors connecting, forming a massive IoT network and a wireless sensor network, again connecting through a drone, connecting to a gateway for massive IoT and all, right? So plus there are several upcoming technologies that people are discussing. We are not looking at only RF based communication, or not only sub 6 gigahertz or millimeter wave based communication. People are also looking at visible light based communication, right, or device to device communication. So there, again, I will not go into details of each one of them, but my motivation of including all of this is to just highlight to you guys that the order of complexity that the network is going to have is going to be exponentially larger than a 5G network, because we are not expanding only in terms of technology. It's not that in 5G we had regular MIMO and in 6G we only have massive MIMO. We have massive MIMO also, we have tiny cells also, we have cell-free communication also, terahertz communication also, visible light communication also, fluidic antennas, right? So now, because the network is evolving in so many dimensions, performing compute for such a network becomes a big bottleneck. And that is where hopefully quantum will come into picture, in particular quantum computing for the compute part, and quantum machine learning for the prediction and the classification tasks. And but of course, all will coexist. It's not that all of a sudden, if quantum computing comes into picture, the regular machine learning will move out. No, because these are deployments you're talking about, right? So if 6G happens first, there will be deployments available which are inherently using machine learning in the network. And again, various types of algorithms. I'll not go into the detail of each one, but you can have supervised learning, unsupervised learning, deep learning, DNN-based architectures, right, or CNN-based architectures. So there, because these are going to be native machine learning supporting networks, it's not that we are going to remove them and then redeploy quantum machine learning based nodes. No. So expectation is for 6G and beyond, we initially will have ML based 6G, and then we will have quantum ML based and quantum computing based augmentation into the 6G network. So my understanding is that as we go forward, various quantum machine learning models like quantum supervised, unsupervised, and RL, neural network, and all will come into picture. And then because there is also going to be this cost benefit analysis, right? Because if you are going to use a quantum neural network, in the initial stages, it's not going to be cheaper. It's going to be most likely costlier than a regular neural network. So then we'll have to figure out that in a 6G deployment, where I should be using a traditional machine learning setup, and in which are the links which are worth deploying in terms of cost, a quantum ML based solution. So that is one kind of research that I foresee at the intersection of these three. Another thing is in terms of quantum compute itself. So one thing that is probably not highlighted here is that all the technologies that are highlighted in the figure are using some sort of compute. It could be something as small as a sensor running a microcontroller, or using a microcontroller for its computations, to something as big as the core network using cloud or a network cloud. But in this whole spectrum of compute, current compute is all digital, regular, binary representation based compute. Now, when quantum computing happens, we will be replacing part of these. But again, the question would be, where it makes more business sense in the initial days. It's not that all of a sudden everything will be replaced, right? So every IoT device may not become a quantum computing based IoT device. It might become prohibitively costly as a device itself. So then most likely what I foresee is more from a core network perspective, that the network clouds will be using quantum compute based solutions, and then gradually they'll start shifting towards the edge, towards the access network, and most likely beyond 6G is where we'll see a lot of deployment of quantum computing based solutions very commonly within the network. Otherwise, my gut feeling is that in 6G context, most likely it will be limited to the core network part because of the cost factor involved. So those are the kind of things that I wanted to cover as part of today's session. Maybe I will briefly, I'll skip the ML part. I had these as backup slides in case the background is not there. Some more, so I think these part, the challenges I have already covered that I foresee in terms of AI, ML and 6G together. So we already discussed explainability, we have discussed the bias part, then impact in terms of efficiency and the cost and the security, right? Maybe a couple of more use cases that I want to highlight where we foresee quantum. One is Industry 5.0. So in Industry 5.0, we are looking at again manufacturing, transportation, energy, healthcare, agriculture perspective, various upgradations compared to Industry 4.0. And there, these are some of the key enabling technologies for 5.0, which, and one of them is quantum computing. But of course, if you, as you see here, it says in future because it's not commercially available yet, right? So, but hopefully in near future is going to marinate with 6G and let's say federated learning and all and big data to ensure Industry 4.0 has a lot of impact. Where again, some of the technologies, so within Industry 5.0, I wanted to highlight some technology that I foresee quantum having a lot of impact on. One is a digital twin based architecture. So already everybody is talking about digital twin in every context. So people are talking about digital twin in manufacturing, digital twin in agriculture, digital twin in healthcare, transportation, even in communication also. People are talking about creating digital twin of the network, creating digital twin of the node itself. But the challenge is, moment you talk about digital twin, you also have to define what do you mean by the digital twins. Because, for example, you can have a physical entity which is running a lot of data. This data is being fed into through a communication layer to a virtual entity, which is a digital twin. And at the same time, you have different services running which are interacting with the physical entity as well as the virtual entity, which is a digital twin, right? But this digital twin, and let's take an example here. So in this particular example, we are looking at some sort of manufacturing conveyor belt kind of a scenario where you have various units, which on the left side, as you see here, we have different units and we are synchronizing them with their twin in the network, right? So it's a physical entity and this one is a digital twin that we have created. Right, and this can be used, for example, for predictive maintenance, anomaly detection, optimizing our operations, optimizing scheduling of your manufacturing unit itself. Now, again, we can have this for, let's say, cyber physical systems. So you can have different type of cyber physical systems, and we can use digital twin technology to create a twin of these. And this can enable, production factory environment for autonomous vehicles, for intelligent devices. Right, but there, one key challenge is at what level we perform the digital twin. So we can have digital twins which are like for performance, to enhance the performance. We can have a digital twin for the process itself. We can have a digital twin of objects, right? Where let's say you're emulating or simulating a rocket, for example. We can have it for phenomenon. We can have it for assets. Now, across the spectrum, if we are applying, and there are also tools available for each one of them, right? So you can have Autotest, for example, for asset DT and also, so there are tools available which are already doing it for Industry 5.0 or enabling this for Industry 5.0. But the moment I say I want to have a digital twin across the spectrum, then the current compute is not enough to support such a scenario. And that is where the quantum compute part comes into picture, where it can enable, for example, I foresee it enabling significantly the digital twin architecture or hard, representation across these various categories, right, together. So that is all that I wanted to cover as part of today's slide. For all such talks, I try to give an overview of our department. This is mostly to attract students, like grad students. So if you know anybody who is interested to pursue a master's or a PhD program, this is my email address. Please feel free to share it across, and I'll be happy to guide them, help them through the process. So maybe I'll conclude here the talk part, and we can discuss if there are any comments, questions, or queries. I'll be happy to answer them. Yeah, thank you.
Okay, participants, any queries, you can raise your hand. We can unmute yourself. Any participants, any queries, you can just raise your hands. Okay, fine. Okay, one doubt is there. Just a minute. Yes, sir, you are unmuted.
Yeah, good evening, sir.
Hi, good evening. Please tell me.
Thank you for your wonderful presentation with all the diagrams and everything. It's a nice presentation, sir. And I have one doubt regarding this research area, sir. In India, currently we are using 5G, no, sir?
Yes.
Even that 5G is not established on all cities. I think it is in a few metro cities only.
Yes.
But what about 6G, sir? In where 6G is using and where the research work is going on 6G, sir?
So I say please note for 5G. So maybe two parts. I'll try to answer them. One is in terms of deployment. So currently 5G deployments are available in let's say the more urban areas, more metro clusters and all, like these bigger cities in because it is commercially more viable to deploy there, because there are users who are ready to pay that extra cost. Please note, any such network deployment inherently comes with cost, because if you are deploying 5G network, there's a huge amount of cost in terms of network infrastructure, significant amount of cost in terms of spectrum purchase also, right? If you recall last year, certain folks paid, certain companies, I don't want to name them, but certain companies paid around few hundred or maybe close to 1,000 crore for spectrum for 5G. So the cost of deployment of the network is so high that people would like to retrieve the investment in terms of money as soon as possible, right? Because if somebody is investing such huge amount of money, they want to make sure the business is viable. And that is the reason the deployment has mostly been currently limited in the Indian context to urban city clusters, because that is where there are users who, when I say users, I mean large number of users. There is a large number of users there who are ready to pay. So that is the reason why the deployment of 5G is restricted in the Indian context so far, and not as widely available as, let's say, we used to have for 2G. So if you recall, for 2G deployment, government had mandated, like, you need to cover 99% of the geographical area. So accordingly, if even now those networks are functioning, so if you go slightly outside the city, it drops from 5G to 4G to sometimes 2.5G or something also, right? So that is as far as the deployment goes. Coming to the 6G part, it is currently under discussion. There is no spec available. The specs are being discussed. Hopefully within next 4 to 5 years, the specs will be finalized, and maybe another 4 to 5 years, so potentially 10 years. And that is how every telecom generational technology has evolved. Every 10 years, typically there is a next deployment. So 4G was, let's say first 2G was in early 90s, and then the 3G happened in early 2000s, and then 4G happened in 2010 to 20, and then now 5G is happening in 20 to 30 kind of time frame. So most likely after 2030, 2035 only we'll see any 6G deployment happening. Currently, even the spec is not finalized. So that has to be finalized, then hardware will be available commercially, and then the deployment will happen. I hope that answers the query in terms of the deployment part.
Okay, sir. But some countries, they are using 6G, no, sir, in the US and China.
No, it's mostly research phase. Currently, there is no deployment. It's all being researched, including in
part of
part of research.
right.
Yes.
Right.
In
Right.
Indian context also, there are people who are, there are the groups working on this, including our own institute. We have several folks working in the 6G context. That includes both from the core network side as well as on the access network, physical layer, massive MIMO kind of setups also, including autonomous driving navigation. There is a lot of research happening in the context of 6G in Indian institutes also. Yes.
Okay, okay. Thank you, sir. Thank you. Thank
Sure.
you.
Thank you. Thank you. I think there is one more query. Uh, Professor Papi, can you unmute the person? I am not able to unmute the other person who is a query. There is another raised hand. Sorry,
I think
or anybody else from the organizing team. Yes. Yeah.
you can unmute yourself. I've printed.
Mr. P. Vijay, you can unmute.
Any other queries? If any other participant wants to ask any question, please raise your hands. Okay, then I think I guess no queries. Shubhadev sir, you can continue.
Yeah. Thank you, ma'am. Thank you, Abhinav sir, for your inspiring speech. So now moving on towards the end of this session, we have already completed our day 4 of this FDP. So let's invite Dr. Satyabrata sir again for his vote of thanks to end the session today.
Yeah, good evening, everyone again. It is my privilege to extend a sincere vote of thanks to Dr. Abhinav Kumar sir, Professor IIT Hyderabad, for delivering an enlightening session on role of quantum computing and AI in next generation communication networks. Sir, your session was a perfect blend of advanced concepts and practical applications, offering deep insights into the transformative potential of quantum computing and AI in shaping future communication networks. Your clarity in explaining these cutting-edge technologies and their integration has provided us with a comprehensive understanding of their importance in revolutionizing the field. On behalf of the organizing committee and all participants of this 6 days online FTP, I extend our heartfelt gratitude for your valuable time and effort in sharing your expertise. Your session has been a true inspiration as always, motivating further exploration in these emerging domains. We will be meeting you, sir, again on the on the last day with another inspiring session. Thank you once again, sir, for your active participation. Thank you.
Thank you. Thank you, Professor Satyabrata, for the kind words, and thank you again, all the organizing team members, for inviting me. And I look forward to the session on Saturday. Thank you.
Thank you, sir.
Thank
you.
Good night. Bye.
Good night, sir. Thank you, sir. Thank you, all the participants. So we have come to the end of this day 4 of the FDP. Tomorrow again we will meet at the same time. So please stay tuned. Good night.